we have to move the constant to the other side of the equal sign, so everything with the variable on one side, the constant on the other. Third, we are trying to build a perfect square. And so to do that, I told you you are going to take half the coefficient of x, square it, and add that to each side. Okay, if you think about, when I say a perfect trinomial, you don't necessarily have to write this down, I just want to talk about it. Right, so if I'm looking at these perfect squares, if I were to FOIL these out, if you look on the right-hand side, how are these two numbers related? Yeah. 10 divided by 2 is 5, and 5 squared is 25. 8 divided by 2 is 4, 4 squared is 16. 6 divided by 2 is 3, 3 squared is 9. So I'm not just making up something when I tell you you're going to divide it by 2 and square it. It's because when you FOIL out that perfect square, that's the pattern that always comes up. Okay, so we are working in reverse. We are trying to create this perfect square so that we can then factor and solve our problem. So let's take a look at this trinomial. We have this quadratic. Could I do box method here? That's the easiest option if it'll work. Is there anything that multiplies to a negative 14 and adds to negative 4? No. Only things that add to 14 are 1 and 14 and 2 and 7. So it doesn't factor nicely. That's why we need this other option. So, first step to completing the square, I told you the square term has to be 1, which it is. Step 2 says move the constant to the other side. So I'm going to add my 14 over, and I'm just leaving myself a little space there. Step 3, we have to make something that will factor. So we are going to make a perfect square for ourselves. To do that, I take this middle term, that negative 4. I will divide it by 2 and square it. Negative 4 divided by 2 is negative 2. And negative 2 squared is positive 4. It's an equation, so whatever you do to one side, you do to the other. So I add 4 to each side. Everyone understand where that 4 came from? Now, we have made a perfect square, so this will factor. We can do box method, but because it's a perfect square, it will always turn into something squared. All right, sometimes you might just be able to look at it and tell what two numbers multiply to 4 and add to negative 4. Bless you. Negative 2 and negative 2. So this factors into x minus 2 squared. A good trick, if you look, negative 4 divided by 2 is negative 2. Whatever that number was before you squared it is always going to be what ends up right there. Okay, 14 plus 4 is 18. Now, if I'm trying to solve for x, how could I get rid of this square? Square root. We can use that square root method from Friday. So anytime you add a square root, you have to do a positive and a negative with it. So we have x minus 2 equals plus and minus. All right, 18, what can I break that into? Square root of 9 is 3. We have a radical 2. One step away to get x by itself, I have to add this 2 over. So I get x equals, I'm just going to write this as 2 plus and minus 3 radical 2. You could put that positive 2 on the end, I just wrote it in front. A lot of times your answer might look like this. It'll have a radical in it, or it might have an I in it when we're all said and done, because the original didn't factor, so it's not going to be a nice, pretty answer. Any questions on how I got that? Let's do another one. I think I'm going to do this one first. First step, we have to have a 1x squared, which we did. What's the second step? Now we have to figure out what to add to each side. So we take that middle term, that -2, we will divide it by 2 and square it. So -2 divided by 2 is -1 squared, +1. So I add 1 to each side. So this is a perfect square, so it will factor into something squared. What's going to go in my parentheses? Remember, an easy way? -2 divided by 2 is -1. To get rid of a square, we square root, and with that you need a positive and a negative. So x minus 1 equals plus and minus the square root of 3. So final step, add our 1 over, so we get 1 plus and minus radical 3. Now it is possible, if these are like terms, let's say you got 1 plus and minus 3 at the end. Could you solve that? Yeah. 1 plus 3 is 4. 1 minus 3 is -2. So if they do happen to be like terms, go ahead and simplify it. But otherwise, if one of them has a radical or something, you're just going to have to leave it like this. Okay. Last one of these. Okay, what is the first step to completing the square? We need that a to be +1. If it is anything else, we have to divide it by that number. So I am going to divide everything by a -4. Both sides of my equation. So -4 divided by -4 is a 1x squared. 8 divided by -4 is -2x. I'm just going to leave that as a fraction, -7/4. Okay, second step is to move the constant to a side by itself, but it is already there. Then, what do we do? Right, when you figure out what we have to add to both sides. So we take that middle number, -2, divide it by 2, and square it. And that gives me +1. So then this factors into an x minus 1 squared. -7/4 plus 1 would be a -3/4. Square root, plus and minus, of -3, that would be an I radical 3, over square root of 4 is 2. So we can break it up and do the square root of the top and bottom separately. And final step, you add the 1s. You get 1 plus and minus I radical 3 over 2. Questions on that at all? So completing the square works for any quadratic that I can do. It's usually not the preferred method. Most of the time you guys don't overly use it unless I tell you to, but there are situations where we have to have this technique, mainly when we get into the graphing and things later on, so that's why I wanted to go ahead and go over that now. What is the other thing that you can do? No matter what quadratic I give you, it always works. Box method sometimes works. It's the fastest, if it does work. Quadratic formula. No matter what, if it doesn't factor nicely, you can solve it with the quadratic formula. So you want to jot this quadratic formula down. X equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. This was, I think Miss Keller had it painted on her wall right above the board. To use this, we do have to have our quadratic equal to 0, but that is the only requirement. You know, to do box method, we need a to be a positive. To do completing the square, we need a to be 1. It doesn't matter in the quadratic formula. It can be anything. So let's do this one. Alright, so I will set it equal to 0. You add your 2. Then in this, what is my A value? 1. B is -4, and C is 2. Just those coefficients. So then if we did the quadratic formula, x equals the opposite of b, opposite of -4, positive 4, plus and minus the square root of b squared minus 4ac all over 2 times a. Under my radical, I get 16 minus 8, which is 8, over 2. Am I done? No. Break apart your radicals as much as possible. So 8, you could break into a 4 into 2. Square root of 4 is 2. And if I divide everything by 2, we get 2 plus and minus the square root of 2. Do you guys remember the quadratic formula using that? Do we need more examples of the quadratic formula? If somebody wanted more examples, would you speak up and tell me? It's encouraging. Okay. I want to talk about one more piece. Sometimes we don't necessarily care what the answer is, we just care what our answer might look like. Okay, when we're talking about quadratics, we've seen all the problems you had for today. You got 2 answers, right? 2 real answers. Sometimes, though, I get 2 imaginary answers. Or, if I gave you something like x squared minus 6x plus 9 equals 0, what does that factor into? X minus 3 times x minus 3, or squared. And in this case, I really only get 1 answer. Do you guys remember I told you what repeated answers are called? Multiplicity of 2. I got the same answer twice. So you might get 1 answer that works twice. You might get 2 different real number answers, or you might get 2 different imaginary answers. And we can find that, determine which case it is, without solving the full quadratic. All we need is a portion of the quadratic formula. If you're looking at your quadratic formula, what about this could make our answer turn imaginary? If I want to know if my answers are going to be real or imaginary, all I really need is that part under the square root. That has a special name. It is called the discriminant, that b squared minus 4ac. If that is a positive number, you get 2 real answers. If that is equal to 0, something plus 0, something minus 0, you only get 1 real answer. You get the same thing twice. And if that is negative, that is when you get the imaginary answers. So I may ask you some questions and say, without solving, tell me what types of answers you're going to get. So that is the discriminant. You might want to jot something down here. So if I don't actually care what the answers are, I just want to know how many real answers are we going to get. What are my answers going to look like? We do have to make sure it is equal to 0, which this one is. What is my A value? And B? And C? Okay, so discriminant, it's just the part under the radical in the quadratic formula, so b squared minus 4ac. So we have negative 5 squared minus 4 times 3 times 1. And I did get a discriminant of 13. So what does that mean? 2 real solutions. One more. Let's say I gave you this one. What do I need to do first? Alright, I need it to be equal to 0. to bring over that 1/2. So then, my A is 3/4, my B is, and my C is, so B squared minus 4AC. You get 1/16 plus 3/2, so I get 25/16. So what does that mean? Too real again. Okay, what would make it imaginary if that turned out to be negative 25/16? And what makes it one repeated, or only one real answer? If it's zero. So we just have to be able to find that. Any questions there? Okay. So I am done for the day. We've got a good amount of time left, so a couple things I want to talk about. Your homework today is a handout, which is already posted on Classroom. And it kind of reviews everything from this section. So it starts out with solving quadratics. It has some where it's just square root method. It's got some box method. Don't forget your greatest common factors. Second page, it's got the stuff we did today. Completing the square, quadratic formula, and the discriminant stuff. If you paid any attention to the board, tomorrow I would like to do our first quiz before we move on. So in chapter 1, we've covered really sections 2, 3, and 4. I'm skipping section 5. And so section 6 is pretty long, and I thought it would probably be better to do a little quiz over that before I move over what we've done and before I move into anything else. So your quiz, I will probably do 1 or 2 review problems at the beginning. There'll be a portion of solving quadratics, so like the front page of the handout today would be pretty good practice for that. The complex number stuff from the day before, you guys did really well on that assignment, so I'm not worried about it. And it also has the word problems on it, which I know have been a little bit longer. So I'll probably do 1 or 2 word problems with you at the beginning of class tomorrow as a review, if that's all right with everybody. So there'll be 3 word problems. One of them is going to be like a picture one, something about the perimeter of a rectangle. One of them will be distance, and one of them will be mixture, because those are the main types we covered. But I will do a review problem or 2 tomorrow. And you can certainly come in before then if you need any extra help. So you've got the rest of the hour to work on this homework, ask questions, check it, all that.